So everybody can see?
Yes, sir.
No, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. This course is basically about
Sir,
computer
this is
programming
not visible.
and yes.
Sir, this is not visible.
It's not
So it is.
visible.
So it is visible. It is visible.
Yes, it's
Sir, it
visible.
is, sir, it is visible.
Okay, sir. Now it's visible, sir.
Okay, thank you. Okay, this course is actually what you can see is basically a computer programming and numerical methods. So there are three parts of this course. Now the course since it has been the whole course has been actually reduced. So I'll try to take some extra classes also in between. So the advantage of being in an online class is that we can take advantage of our Sundays and our Saturdays also, right? So I'll take some times from you at the later time, not immediately. So the first part is of yours. If you actually see your syllabus, that is it's available in the website also. It's basically first the first line states that the history of computers, then there will be some then how the programming language comes, then there will be the history of computers. You please have a look at all. There are lots of data available in the net. So if you're very much interested, so I'll start off with where you're actually starting off with your programming part. Okay, so that over there will be two concepts. There will be two or three things. One is basically the this thing. One is your how to make your algorithms, how to design algorithms. So designing algorithms comes in the forms of okay. First thing, let's see what is an algorithm. Algorithm is actually what you can say. Uh, they are basically a set of instructions. Okay, it's a set of instructions which instructions are finite instructions. So no instruction, you will not actually give any instruction which actually tells you to do something infinitely times. So these instructions are ever finite. These instructions will be taking have finite times, and then a finite set of instructions. Okay, these instructions they have, but if these instructions they are written in some formal way. But then, let's take for example, uh, uh, you are asked to basically write the simple interest of a certain given not let's take for example, not simple interest. Let's take for example your you want to add two numbers. Okay, so what can be your can anybody tell me that what can be the steps of basically adding two numbers? Anybody? Yeah, Pratik.
Sir, at first we have to read the two numbers and then we have to add the
Okay,
two
what do you mean
numbers.
by reading? What do you mean by reading?
Sir, getting input.
What do you mean by an input?
Sir, input means
Converting
that.
into a binary system.
Wow, wow, wow. Okay, okay. You're running away very fast. Let's take an example. Let's take for something you are trying to explain this. You're trying to explain a method to add two numbers to a student of class 1. Okay, so how will you do it? Yeah, Shatri.
Sir, first selecting the numbers and then teaching them how to add, like how to use the function of addition.
So okay, let's assume that they already know how to add these two numbers. Then what? I'll assume that that your student has knows how to add two numbers. Then what will you do?
Then first thing we need to select the numbers which are necessary for the addition, and then after that, like if he knows addition, if he knows subtraction, then he needs to choose which function he will use for the
Okay.
problem.
Okay. Can you give me the steps right now? So this is basically an abstract way of saying that it's an abstract way of saying that what you want to do. Okay. Now give me the steps. I want to know the steps. So it's something like step 1, step 2, step 3, something like that. Okay.
Sir, first of all, we'll if the numbers that we are going to add, if it's going to be supplied by not selected by us, then we are going to take two variables, say A and B, and then we're going to ask the kid or anybody else to give us two numbers, and we are going to assign the first number to A and the second
You are
number to
again
B.
give me a paragraph. You are again basically just telling, give me a story. You are giving me a story. I don't want the story. I want the steps.
Okay, so step one, we can take A. We can take input of A. Step
Yeah.
two, assign that input to A. Say that syntax for that will be decided by the programming language. I'm not saying that.
Okay.
And step three, we can take B is equal to user input that number. Then we can take we can assign another variable which will be sum, say S, and step that is going to be step 5. So step 5 is equal to A plus B. And
Okay.
then if we have to print the sum, then we will just print sum in the next step. Say step 6 can be print S.
Yeah. So these but it's just what you had just said, you can but this is some sort of an algorithm, you can say. So if you actually notice, no step has got an infinite number of time you can basically take. So you're gonna take, okay, you assign some variable, you for that you take an input and you assign a number to that same variable. You take another input, you assign that number to a second variable, and you add those two numbers. You add those two numbers, as you were saying, that S is equal to A plus B, and then you basically show that show that basically that sum. Okay, so and for doing this whole addition, there is a finite number of steps. So there are if I mean to say that finite, it means that basically you can count the number of steps. It's not an infinite number of steps. Okay, so this is this is one way of basically saying what an algorithm is all about. But then there are structural ways of actually also saying that to design this whole system. So there are two ways of designing algorithm, to actually design algorithm. One is what we see as a flowchart. Another is basically what we see as an algorithmic pseudocode. What was just said right now, that was almost like a pseudocode. Okay, a pseudocode. The word pseudocode means that the steps actually can be interpreted as a simple code also. A code is a specific in a certain program. Okay, now who can tell me what a program is?
So program is a set of instructions.
Okay, a program is a set of instructions. Okay, can you tell me a little bit much more explicitly? Okay, Shatoki?
Sir, a program is a language that we have invented for the computers to understand what our needs are.
Can you please repeat it?
Program is a language that we have invented for the computer to actually understand what our need are, because like we generally converse in languages like Bengali and English, but for computer we need to provide some specific steps in specific languages. So that's what a program is, I suppose.
Okay, can anybody else actually give a little bit much more explanation? Rajeshri?
Yes, sir. Programming is a process of taking an algorithm and encoding it to a notation, and so that notation means instruction on that.
Notation or instructions. Okay.
That can be executed by a computer.
Okay. I'll take your word for that. I'll take your good word for that. Anybody has got to anything to add, Roma?
Sir, a computer program is a set of instructions which is required to perform a particular task.
But then that is also an algorithm also. That algorithm or algorithm on the pseudocode, that is basically does the same thing also.
Sir, a program is an algorithm expressed in proper syntax.
Proper syntax. What do you mean by a syntax? Where does the syntax coming from?
We can't like a computer.
My first question will be, what is the syntax?
See, sir, a computer can't just understand any algorithm that we write. so it has to be given in a way that the computer can understand. Otherwise, it will just be gibberish for the computer. So, a programming language is a set of principles, is a given, is like a foundation for which that can be used to convey our logic to the computer.
Convey your logic to your computer.
And
Okay.
a program is basically an algorithm written using that logic or using that syntax.
Okay, everybody, what you have said is, I won't say that you are absolutely correct, but then you are almost always everybody partially. Let's think it from a very naive view. Okay, let's say you are teaching a child how to speak. Okay, so how do you actually start off with? You actually start off with basically teaching him the symbols of the language. Let's take for example, if you are actually doing it for English, so you have to teach him basically A, B, C, D, E, F. Then you have to basically teach him how to join those letters to form words, and then you also have to teach him the grammar of the language for the English language. So you have to teach him what is a noun, what is a pronoun, what is a how to basically combine these noun, pronouns, and all these verbs and the tenses to actually construct a sentence which is meaningful. Right. So one can form a sentence. One can one can actually group many of these words together and not also make sense. It is very much possible. Right. But the main objective is to actually make a sense out of all these words. So for the programming language, what the 2 or 3 things what it has got some words, some keywords, and then it has also got a grammar. So you use these keywords and you use all these sorts of you use all these sorts of keywords and all these sorts of language statements, all these tenses which you have learned, and you combine them to form a meaningful set of instructions which are again finite, and that whole set of instructions will be as similar to basically writing giving you giving a code, or what do you say, making some sense out of it. So over here, any programming languages, whenever what we will be basically starting off, we'll be starting off with C. Okay, we'll actually basically go through C only over here. So C programming languages, it has got some set of variables, it has got some syntaxes, specific syntaxes. Okay, and those syntaxes are actually basically joined together to form a program or something meaningful out. So these syntaxes is basically formed of the grammar of which is actually defined by the C language only. So if anybody of interest, when each and every programming language has a grammar. Any programming language you take, some of you know how many. Okay, just one inquisitiveness. How many of you do not know how to do any sort of a program? So 3. Any sort of a program. No programming idea. Okay, not bad. Okay. Okay, not bad. Not bad.
Sir,
Huh.
I'm telling that, sir, about the computer, I don't know anything, sir. That's why something I could not understand, which you told just right now.
Go ahead. Okay, now you basically, what are the questions? Go ahead, Ishan. What are the questions you want to ask?
Basically, what was the programming, sir? I could not understand, sir.
A program actually a set of instructions written in a specific way, such that it follows the grammar of the program. So the program, you can actually say it comes from a set of instructions. Okay, it comes from a set of instructions. Those instructions, you will be taking them and you will be actually combining them together to make a sense. Let's take, for example, if I'm talking of English language, you already know what is a verb, what is a tense, what are the letters. So what you actually do to actually make a sense out of a sentence, you have to follow the grammar, right?
Yes, sir.
Okay. Similarly, any programming language, that is why we say it's a programming language. So the word language is already existing over there. Okay, so the language, since as the English language, you have got a grammar, you have got some words, you have got some tenses. Similarly, for a programming language, you also have this grammar, you have also got these set of words which you're going to use and combine together to give you to help you to write something which will make sense. In this, the word for a program to make sense is means that you will be basically giving you will give him some instructions, and it will give you some instructions. It will give you some information. Okay, Shad. Any question?
Sorry, sir. This one you are asking about the instructions. So
Instructions, okay, for that instructions, bear with me, because then as I'm going to yes, Shuja, I know it's basically lagging a bit. Unfortunately, my net is basically revolving around, unfortunately. But bear with me, because when I'm going to come into the programming languages, that is when I'm going to teach you C, when we're going to go through C, you will see that what all these syntaxes are, what all these keywords are. So just know that instructions, these instructions are formed from from the syntaxes, and joining all these instructions and all these keywords and which is available for a programming language, for a given programming language, you can form a finite set of instructions. You can make a finite set of instructions which will help you to process some data, out of which you can get some information. So can anybody tell me what is the difference between data?
Sir, repeat
So
the
didn't
question.
get
Sorry, sir, you are not audible.
So repeat
Hello.
the question.
My question is that what is the difference between what is the data and what is information?
Sir,
Sir,
information is a
Sir,
process data.
information is collection of meaningful data.
Information is a collection of meaningful data.
Meaningful
The
data.
process data. Otherwise you can say.
Process data. Anything else?
So data is in the raw state and information is in the refined state.
Okay. So both sort of, and what Chandan both gave basically, they are almost what you can actually say. So data is, it's not it's basically raw, in raw format. So which on these data you're going to run these instructions which you have actually done, you have actually used, you have actually basically made, and out of it you're going to be giving some information. So let's say for addition number, for that addition of two numbers, so your data was that two numbers which you are given, and what was the information? The summation of the two numbers information. Okay, so the data can be anything. So nowadays everything is a data, and the target is that basically to actually help take a set of these data and process them, and in that sense I'll give you some information. Okay. Syntax. Syntax, yes, syntax, you can say that syntax is some sort of a sentence also. Yes, Jayant. You can say a syntax is basically a sentence which follows a set of grammar, which follows a.
Okay, sir.
Try to think it in the terms of basically your what do you say, your programming language as a language which you already know. Okay. So So what so the process of basically now what you have got, these programming languages, they have got a set of syntaxes. Now, unfortunately, there is a little bit problem. The problem is that the machine, what your process will be done with the help of a machine, right? A machine which can compute. This is a very important thing. A machine which can compute. So all machines are not computable machines. Right. So let's take, for example, let's take what do you say? It's a machine is weighing. What do you say? Mm, a machine can be also something which actually can fit two or three two or three objects together. Right. So let's take, for example, you want to design a machine for joining two lead balls. So what are you going to take? You will be having two grippers, right? You'll be having two hands for that machine. Then it will basically take it sum up, and then you'll be using a joining system. But then this is a machine, but which cannot compute. This is a machine which cannot compute. So what we require is basically a machine which can compute. So a machine which can compute it is as good as basically what we see as a computer. So computer is technically a machine which is which machine is something which can compute. So even in that sense, a calculator is also a computer. But all computers have each and every computer has got limitations. So similarly, a simple calculator will have a certain limitations of a scientific calculator which you'll be using, that will have a many more functions. So that is a better computing machine than a simple calculator. And you have got a desktop or where you have got many sort of a processors and all those things. That is a far better processor. Has got a far better processor than what simple scientific calculator has, because it can do many more computations. Many more computation. The problem is that these computations, what is being done, they are done in a simple thing what we see as a processors. So computing machine will have two or three parts. It will have an input and what do you say? System through which you can do some input. A system through which you can do some where there will be output, and these will be basically taken to some to a processor or to some processing system which we see to be as a processor, and this processor will take all these data which you have taken from this input system and will do some processing and will take it back to the output data. So for a desktop machine, your keyboard can be an input system. Display system, your display can be your output system, and your processor is what we say as your this thing as your Intel processor with the RAM, random access memory, and there will be a read-only memory. Okay, so these combines together, which actually helps you to do some processing for that data. Now, these processors, unfortunately, they cannot communicate. You cannot do anything with these because they actually work with simple signals of zeros and ones. Simple signals of zeros and ones. So what you require is that now, since the machine can understand in the form of zeros and ones, it is not possible for you to do that. It's not possible for you to do that. So I require something a higher system, a higher system through which I can actually communicate with it. So that is basically what you see as a programming language. So a programming language has got codes or has got syntaxes which can be easily understood by us human beings. Then what happens is that this code is being taken to the processor, it's been cut through between that, it's been converted into your zeros and your ones, right? Zeros and your ones is being processed, and then is basically it's being basically outputted to your output display through a proper through a proper language or through a proper communication system which you can understand. Okay. So in this example, in this thing, let's take for example, for a C language, your will be a C program. Your C program will be compiled or will be basically processed through some other ways to form into a language which the machine can understand. That is specifically being said as a machine language. So machine language is basically a form of a zeros and ones. Now these zeros and ones, what we say, these are said to be as binary numbers. These are binary codes, right? Technically, a 0 and 1 is actually a simple on and off. If you have got some switches, so when you basically, let's say I've got a set of switches, right, which puts of light, which puts on a light and puts off the light, right? So if I've got 8 switches with 8 lights, so if I give basically combinations of zeros and ones together combined, so it will give you a basically lights of offs and ons, a sequence of offs and ons. So these offs and ons can be also interpreted as zeros and ones to your computing machine. Okay. Any question?
No, sir.
Sir, could you please?
Yes.
Sir, could you please repeat the last sentence?
Which one? Okay, okay. What happens is that basically I've got a program. The program is something which you as a human being can understand, because you as a human being cannot understand the zeros and ones. That would be tough for you, right? So you write your instruction set in a set of instructions given through a program, right? That program is being processed in some way or the other to actually convert it into your machine language program, machine language format, which is being used to run through the processors. So there are two things if you actually see. If you actually see this thing, so you have got an idea which is to be sent, which you have got an encoder which actually encodes. So what is your encoder over here? So the idea is basically your C program. Your encode codes your idea to a set of instructions which the information, which the medium can actually sense. So this encoder sends it through the sender to the medium, and it receiver receives it, and that receiving data is again in the machine code, which this receiver basically decodes into the language which you know, which you can understand, and then we have a response. So this is one way of basically setting up. This is basically, even if you can think of it, this is actually again a communication. So the communication and your response. So this is an idea which you know, and this is the response which you're getting. And these are the set of things, or set of steps in between which this whole idea is being converted to a response. Okay. So let's go. So what is the programming? So you'll be having a programming language. So programming language is a series of specifically defined commands. Now each and every programming language, they have got their own set of commands. So you already know of some programming languages, the names of the programming languages: C, C++, Java. These are some programming languages which are very much aware. But these are coming always right now. If you actually go through the internet, you'll finding these sorts of programming languages. So each programming language, they have got a specifically defined commands, and each of these commands, not only they have got a set of defined commands, each has got a set of different different grammar also. Each and every program has got its different grammar. So no two programming languages have got the same grammar. But unfortunately, if the grammar, if you actually see it, in the grammar over here is this in sense is that the way you basically will be combining these commands together to form a set of instructions. Okay, but the logic, unfortunately, if you have got a logic, if you have got a system which you have designed through your flowchart or through your algorithm, each and every of these flowchart or the algorithm can be converted into any specific programming language you know. If you actually specific set of commands, defined commands, which is given through the programming language. So the main objective in the beginning is to actually design your program, design your system, or design your idea. That will be a main objective. So to do that, okay. Just come back. So okay, let's take some hints. So we'll get to what is basically an algorithm, right? So we'll first see that how to design. So the designing of the idea will be done through two ways. So one is basically an algorithm, and the other one will be a flowchart. So the algorithm is basically, the term algorithm refers to the logic of the program. So you have got a logic. So in the idea, what you require an idea. Let's say you have got a set of numbers and you want to find out the mean of that number. What you are going to do? What you are going to do? So over here, what we are going to take is that we will be taking in some variables. The variable will be similar to what you can say in algebraic system. So I have got a set of variables. So let my set of variables be x1, x2, x3, x4. So I want to take the mean. I want to find out the mean of this set of phone numbers. So I have got my variables x1, x2, x3, x4. After that, I take in the inputs of the numbers of x1, x2, x3, x4. I state that my numbers will be all positive real numbers. So these are my ideas which I'm actually generating, which later on I'm going to program. So I'm going to take some 4 variables, x1, x2, x3, x4. Then I'm going to convert, then I'm going to read, I'm going to basically input those numbers, or I'm going to read those variables with specific real positive real numbers, x1, x2. Then I take another variable, which I say to be an average, and I state that average is equal to x plus x1 plus x2 plus x3 plus x4 divided by 4. And at the end of the day, I'm going to output that average. So these 4 steps, with these 4 or 5 steps which you're going to use, that is an algorithm. That will be basically an algorithm. Okay, let's think of it another way. Let's think of something else. So I have got a set of numbers, say x1, x2, x3, x4 to xn. I want to find out the frequency of each number which I'm going to take. And assuming that x1 to xn will have numbers between 0 to 9. So what we're going to do is that you're going to read x1 plus x2, x1, x2, xn to xn, right? So this is the one way out. And then I'm going to, so let's do something like this. So your step 1, so my left hand side will be, can everybody see my screen? Hello? Yes, sir.
Yes.
Yes.
Yes,
Yes,
sir.
yes, sir, it's visible.
It's visible,
Yes, sir.
right? So I want to basically write an algorithm for finding out the frequency of a set of numbers, right? So what of a set of input numbers? So I write that input x1, x2, then dot xn, right? Such that xi will lie in xi belongs to xi xi less than equal to 9 and greater than equal to 0, right? Then I want to basically read these numbers. Okay, so what I can do is basically read x1, x2, x3, dot xn. Now my objective is is read to find out the frequency of 0 and 9, 0 to 9. What will I do? Can anybody tell me? What will I do?
So we have to consider a counter.
Just hold on. There are too many things are coming up. So Gaurav, can you tell me what do I have to do? I'll just lower everybody's hands. Everybody has. So, anybody, can you please anybody raise your hands to what you will be doing? Okay, Kushal, what will do?
Sir, we will set a variable and we will read the numbers, and when the number come 0 or 9, we will increase the variable. That's why we will. That's how we will count the frequency of 0 and 9.
Okay, anybody who is not from who does not know anything about programming or anything, there is somebody who does not have any idea of programming language. Who is it? Okay, I'll just lower all. Shujal, you have any idea of basically programming? Shujal?
No, sir.
Okay, you do not have any idea. You tell me. What will you do? Think of it. You don't have to think it in computer terms. Just think it of logically what you will do. I've got a set of numbers. I want to find out the frequency. What did you when you were doing a mathematics, right? When you were drawing a, so basically what you are actually basically trying to find out the histogram, right? You're trying to find out the histogram of a frequency in the form of money. You want to, I'll try to basically find out the frequency of each number, and out of that you want to basically draw your histogram. What will you do? Tell me. What will you do? Forget about programming. Forget about algorithm. Just give me an idea. I'm looking for an idea. Sharup? Give me an idea. I just want an idea. That is. It has got nothing to do with programming. Please note it.
Sir.
Yes, Shatul.
Sir, suppose we need to find the frequency of the number, say 5. So
right.
if we can give a command to count the number of times 5 arrives in our set, then I suppose we can calculate the frequency.
Find out the frequency of 5. Good. That's not a bad idea. That's not a bad idea. Rather, that will be something which I'll be actually doing right now. That will be something I'll be doing. Right. So you're talking of 5. So I'm talking of 9 numbers. Right. So I'll be requiring then 9 variables. Right.
Yes, sir.
Okay. So let's take, for example, I have got variables. Frequency f1, f0, f1 dot f9. So these are variables for counting the frequencies of each number, right? So f0 will, f1 will be for 1, f2 will be for 2, and f9 will be for 9, right? Now, as you were saying, you want to count, right? So for that, if I actually want to think it in this way, let's take for example, I want to, if I have, let's take for a set of variables, and mind it, all these variables, they do have a sort of an index, if you can actually see. So each of these variables have got an x1 is an index, 2 is an index for x2, 3 is an index for 3, and n will be an index for xn. So if I say that I want to traverse from the variable x1 to xn, and if I see that if x1 is a 0, then I'm going to increment my value of a f. So that means I have found out the value of 0 is over there, right? So I'll just increment the value. So in my beginning, my values must be 0 then, right? So I'll do something. Let's take for example for traverse. So let's take for example, this is my x is a, this you can say x is equal to something like this, right? So this is a set traverse x, traverse x, traverse x, traverse x.
Sir,
Yes.
what is traverse, sir?
So I'm going to traverse. Traverse means that I'm going to start off from when I'm going to traverse this. Basically, if this x is a set, so I'm going to take each value. So I'll take from x1, then I'll take the value of x2, then I'll take the value of x3. So that is basically traversing. So
Okay,
you're just moving through that whole set. Okay, traverse x with traverse x. Okay, so now so I require a condition right now. Until I do not have a condition, I won't be able to know that what that number represents. So if xi, where I is less than equal to n and greater than equal to 0. If xi, the traverse xi for all xi, sorry, for all xi, so this can be with this thing. Now you see that this means that if I want to basically traverse from x0, so if I, for my first number x, sorry, this one will be, let's take for example x0. If I start from x0, okay. So if I actually say if I start from x0, that means it will be xi for my first step. So when we will x0, that means I is basically 0 at that time, right? Because I'm starting from 0 to n. So if xi equivalent to, so I cannot say that this has to be equal to, because equal to, if you actually know, equal to is basically an assignment, right? So this is xi is equal to xi equivalent to 0, then f0 equals to f0 plus 1.
Sir,
Right?
can you repeat this one, like the sixth one? Why f0 is f0 plus 1?
Okay, so what I'm going to do, so I'm going to traversing for xi. So xi will be basically a variable sort of, it's basically that xi is the index, right? for the indexes from the x0 to the xn. So my I will actually take values from 0 to n, 0 to n, right? So what I'm telling you, I'm going to traverse x for all. So for my first one, it will be basically x0. It will be x0. So if x0 is equivalent to 0, then f0 is equal to f0 plus 1. What I have taken in the beginning, f0 is actually 0. So so that means my x0 contains 0. My x0 contains 0. If it contains 0, then I'm going to increment the values of f0. That is similarly how you actually, how do you actually find out a frequency of a set of numbers? That is what you did in your basically class 9, 10, 11, 12. Think it of this, how you actually did it in your head.
Sir, actually, I don't hail from a computer background. I didn't have.
This got nothing to do computer. This has got nothing to do with computers. Think it of what you did. You had got a, let's say for your teacher told you, I'm giving you a set of numbers, find out the frequency of that number, of each number.
Sir, actually f0 equals to f0 plus 1 is creating some problems, sir. Because of this one, nothing could be understood, sir.
Okay. All of you did mathematics. All of you know what is an average, what is the frequency. All of you know it.
Yes,
how many
sir.
of you do not know it?
Definitely, sir.
You know it, right? Now, let's take for example, I'm giving you a set of numbers. Okay, that numbers, all the set of numbers is ranging from 0 to 9. It can be 100 numbers. You are given 100 numbers of 0 to, each of those basically, all those 100 numbers will be from between 0 to 9. Right? Now I'm telling you to find out the frequency of 0 through 9 for that whole set. What will you do? Tell me. What will you do? This has got nothing to do with computer science. Believe me. It's simple. What you used to do in class, your 9, 10, 10.
Please, can you repeat? I have just missed the sentence.
Okay. I'm giving you a set of 100 numbers. Each number will lie between 0 to 9. Will lie between 0 and 9. All of them are integer numbers. All of them are integer numbers. Right? Now, I want you to find out the frequency of through 0 to 9. Through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What will you do? Tell me.
Sir, we can arrange all the numbers in ascending order. Then we can just simply count.
Okay, let's take for example, I'm not going to interested in basically, you can forget about arranging the system. If you do not want to arrange the system, then what will you do?
Sir, we will just first count for number of zeros, then count for number of ones, 2, 3, and at the last count for number of 9 in the set of 100 numbers.
Now give me the steps. That is what you said that you're going to do it.
Okay. First, I will take the 100 numbers. Take the 100 numbers in 100 variables. Okay. Then
100 variables. So anybody did not understand this statement. He is stating that he's going to take those 100 numbers in 100 variables. How many of you tell me?
Should I continue?
Okay. Anybody? Shantan, you have got an idea? You have got a problem?
Sir, I have one.
Yes.
Like he told us to take 100 variables, but the numbers that we can input lie between 1 and 9, right?
Yeah.
So there will be variables which can have same values, like same values but different variables. So that can create a problem, I suppose.
No, but that is the problem. I'm giving you 100 numbers. Each number will lie between 0 and 9. I want you to find out the frequency between 0 and 9. That is all of all the numbers.
Okay, sir. Okay.
That was the problem.
Okay, then first I will take the
So,
numbers.
Okay, Udit, you have got a problem. Okay, go ahead.
let's suppose we are looking for the number 7,
Okay, okay.
and
If you're giving me the solution, Junaid is already giving me a solution. Let's get
okay,
through this solution, then I'll come back to you.
Okay,
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 Junaid.
first we will take the numbers and save it
Okay,
to 100 variables. Then I
okay.
will search for zeros, number of zeros in the set of 100 numbers. I will count how many zeros are there and
How will you
save the.
count? No, 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 you're stepping a step. The question is, how will you count?
Okay, if suppose a variable is x1, then
Yeah.
and the number which I want to search is 0. So I will check
Okay.
if x1 is equal to 0 or not. If
Okay.
yes, then I will going to increase the number by 1. Then again I will check for
What
x2.
number?
Then I
Whose
will
number?
check
Whose number you're
x3.
going to increase? Whose number you're going to increase?
The number of zeros that will be saved in another variable.
So you are actually keeping another variable,
Just
variable
count.
which
Yeah,
indicates that how many zeros are there, right?
actually how many zeros are there, and I am going
Okay.
to count for x1. Is it okay? If it is equal to 0, increase that variable. Then I am going to check for x2, x3, and then up to x100, and the
Okay.
last one. Now
Mhm.
I have counted how many zeros are there. I will then after that I will print the value that this much zeros are there. Once 0 is counted, then I will go for the next integer, that is 1, and like this I will continue till the last integer, that is 9.
Okay. Anybody has gotten Junaid? Yes, you are that. You are right. That is one way. Anybody has got any other ideas? Udit, you had an idea?
yes. So I was basically saying similar thing. So there are 100 numbers and all ranging from 0 to 9. So 0 to 9 are the other numbers, and if we assign a certain frequency variable, counting variable for each number, f0, f1, as you told earlier, and every time we see a specific number, we will just simply add 1 to it. So ultimately, let's say we are searching for 7, and let's say 7 is there 10 times. So every time we look at the number 7, we can simply just add 1 to it, to the counting variable. So ultimately, we will get number of times 7 has appeared, the frequency of number 7, and similarly we will do for every number, and ultimately we will get the result.
After that, we can put the whole system in a loop.
You are going run. You are running away. I'm not interested in computer science. I'm not interested in computer science. I'm looking for the mathematical solution. Toby, yes? You have got an idea?
Sir, instead of checking all the numbers if they are 0 or not, we could check each number if it is 0. Means suppose we are searching for a number I, means
Yeah.
within I is within 0 to 9. So instead of checking all the numbers if they are exactly equal to 0 or exactly equal to 1, we can check each number if it is equal to 0. If it is not, then we can check that same number if it is equal to 1, and we can continue until it is equal to I, and we can increase its frequency, fi.
Okay. Handika, you have got any idea? Any other idea?
So,
You have got any idea?
so can you repeat this?
You are given a set of numbers, 100 numbers. Each number lies from between 0 and 9, right?
Yes,
I want you to find the frequency of each number that is arising, that is 0 and 9. What will you do?
So first of all, I will take 100 variables.
Okay, you are again talking computer science. I'm not interested in programming. Anybody not from computers, not knowing any sort of a computers? Anybody not from? Okay, Shatoki, go ahead. Meghna? Anybody not sure of what is being said? I just want to know. Anybody is not sure of what is being said? Everybody is all right with the problem statement, and everybody is all right with the two sorts of solution which has been given. You see, there has been two solutions which has been given. One is to find out each number that is 0 through all the sets. And another solution has been given is that to check each number, whether it is a 0 or a 1 and to 2 or a 3 or a 4 or a 5 or a 9 through 9, and then increase that value corresponding to the frequencies, and increase the frequency number of that number increment by 1. Anybody has any doubts? There are two solutions which has been come out. Okay, so what I'm going to do is that I'm going to actually basically take these two solutions. I'm going to take these two solutions. I'm going to basically form it into two steps. Right? I'm going to form it into steps. That is what I have done. I have got to take x1 to xn. Let's take, for example, this is basically x100. For easy things, I started with x100. Now, I'm going to take the second solution. That is what I'll do is basically I'll check each number through this set. I'm going to check if each number lies between a 0, if it's a 0. If it is a 0, then I'm going to basically increase that. I've taken basically in the third line, I've taken basically 9 variables. 9 variables. I have initialized each variable with a 0. I've initialized each variable with a 0. Somebody was referring something like, oh, you can think of them as boxes also. Somebody was saying that Obrojit. So he was stating that you can even think of this F0, F1 to be as simple boxes. Right. So if my xi, this one will be 100. This one will be 100. So if my xi is a 0, then I'm going to increase that box value, that is a F0 with a 1. And I'm going to do it for all other values till I'm going to complete it through 9. Then I'm going to say that n traverse. Is clear from this point of view. I have just basically, you can see that I have just taken your two ideas. I'm taking one of your ideas and I've just converted that into a sequence of steps. So the first thing is that you require an idea and then you convert that idea into a sequence of steps. Then I'm going to do something like output F0, F1, dot, F9. Anybody has got any problems? Anybody? Again, I'm saying this is not computer science. This is a simple converting your idea into a set of steps. I can even actually remove this thing and I can say basically something like this. X equals to this thing. This is also all right. This is also all right. So these two symbols which actually indicate that this is basically a comment I'm telling you to actually state. I'm actually commenting on basically what these variables actually do. Anybody's are not sure about what I've done? Everybody sure? Kandikar, you are sure? Okay. Basically, this word traverse is basically a simple, it's a very typically, yes, somebody.
Excuse me, sir.
Yes.
Sir, you have just written that if x1 is equal to x1 is equal to 0, then f0 is equal to f0 plus 1.
xi.
Xi is equal to 0 and so on till xi is equal to 9. Sir,
Yeah.
we can, after writing one statement, we can also write the repeat the same process for xy lies between from 9 up to 9.
Mm, okay, yes, you are right, but let's skip that state presently. Let's assume that I've got 9 variables.
Okay, sir.
Yes, you are. I can do that also. That is also one way of. But I'll not. I'll try not to make it. Right. I'll try not to make it complicated. But then let's see. Any questions? Any other thing? Okay, let's little bit. Let's not use these words traverse and all those stuff. So let's do something else. Let's say that I am going to do something like this. For all, for I equals to 0 to 100, right? Can I just basically change that traverse from a to a for? So what I'm going to do is basically for I is in a variable, for I is equal to 0 to 100, right? So if xi, that means whenever I is equal to 0, this xi will be x0, right? I is equal to say 50, so xi will be x50. And I'm going to basically do this. So you can see that what I've done, it is for each for, I'm going to actually basically say that there is an end for also. Because if I'm not saying that if the where to end, so there is something I must do, that basically a process is a set of instructions which I'm going to say basically is going to end. Right. So this is a for statement. This is not an please note, this is for not for programming. This is a for statement. For I is equal to 0 to 100, right? If xi is equal to 0, then f0 is equal to 1. If xi is equal to 9, then f9 is equal to 9, f9 plus 1. There are some dots over here, and then n4. So I've just removed that. I've replaced that traverse with a simple statement with a for. Now this for, you can actually say this is something called a pseudocode, because for is an instruction which you will see that they will be actually also used when I'm going to work with your algorithms also, with your codes also, programming also. Okay, so I've just replaced that traverse with a for. Any problem with anybody over here? Anybody has any problem? I just replaced it. That is all.
Sir,
Yes.
hello. Sir, I can't understand the point 8.
Line
Point
8.
9, point 9.
Yeah, point 8 and 7 is basically, this is for if xi. Have you understood line 7?
No.
Huh?
Same. No, sir.
Okay, let's see what is going to happen. For let's take for if I actually do the steps. For my first step, I is equal to 0, right? I is equal to 0. Then this statement will run. So my x0. So if equivalent to 0, then f0 equals to f0 plus 1. Right? Right? So my next step will be I is equal to 1. X1, x1. Then I is equal to 3. I3, x3. So it goes on. Is it all right now? So for I is equal to 0, so for my first step, this is basically what we see as a loop. This is what we see as a loop. Right. So what is a loop? A loop is basically something like I'm doing the same set multiple number of times. Right. So this xi is equal to 0 to xi is equal to n. This instruction I'm going to do it for hundreds of times. Now it is basically useless to actually write hundreds of nine, so that there will be 9 instructions, 10 instructions over here, right? Between 7 to 9 there will be 10 instructions. So if I'm not using this loop, right, and if I want to check each of these 100 lines, so I have to check this if each of these x1 to x100 numbers, so I'll be requiring to write 100 into, I'm sorry, this is actually wrong. I'm extremely sorry, this is actually wrong. This one will be actually wrong. Yeah, this is wrong actually, sorry. Because my number is starting from x1, right? So x0 does not exist. So so I'll be writing 100 into 10, that is 1000 lines of code. So I want to avoid that. So to avoid that, what I'm going to do is basically I'm writing it these same 10 number of steps. These same 10 number of steps. Since this same 10 number of these 10 steps is being repeated for 100 numbers, I'm going to do, I'm basically writing it in loop. That is the for loop. This is the for loop. Similar to a for loop, there are many other loops also. Okay, so what does that actually mean? So for I is equal to 1, then we'll do these 10 instructions. Then for I is equal to 2, is going to do the same instructions. Then for I is equal to 3, is going to do the same instructions till I is equal to 100, till is going to go through I is equal to 100. So I x100. So this is the instructions which is going to go. This is the steps which is actually happening due to this 5 to the 411 lines. Line number 5 to line number 11. This is what is happening between these, for these line to the 11 lines. This is what is going to happen technically. Any question? Please have a look.
Sir, what is pseudocode in there?
The pseudocode is, this is your pseudocode. You can say this is your pseudocode. You can even say this is an algorithm also. This is an algorithm also.
So what you have written after line 16, so those all are happening inside of that, line 7 to 9.
Line 5 to line is being replaced with useless.
Okay.
So it's just a replacement. As I have replaced my traverse, with the for, I'm going to basically replace these line number 16 to your line number 34 with these line number 5 to line number 11. I'm making my set of instructions to be much more compact and much more shorter. Any question?
Sir?
Yes.
So if we can, if we try to short our process, we can write xi equal to I then fi equals fi plus 1, then we can like skip
Okay,
many
now you want
steps.
to basically go for the other part, right? Now you want to basically make my f0 to f9 to be also a variable, right? Okay.
Yes, sir.
So can we do something like this then? So for that, I'll be requiring something new. J is equal to 0 to 9. So if xi is equal to 0, then if j so I've made my my sequence of steps to be much more shorter. Now see what is going to happen. Now let's see what is going to happen. So now my first statement is I is equal to 1, right? Now what I have done is basically I have actually replaced the 10 lines with 10 lines with only 3 lines. So what is going to happen between line number 7 to 9? So this is going to happen is that x if 0 x1, because xi is basically xi is equal to presently is equal to 1 xi. Now my first one is basically j is equal to 0, right? x1 equal to 0, then f0 equals to f0 plus 1. Then we'll completed my 7 to 9 steps. 7 to 9 steps has not been completed. So now will be j is equal to 1. So this one will be 1. This one will be 1. And till it's going to go till j is equal to 9. Then if x1 is equal to 9, then f9, f9. Right? Then my I becomes 2, and again these steps takes place with j is equal to 0, with x1 being a 0, then this one will be 2, this one will be 2, and this one will be 2. So again, you see basically what I have done in the first step, in the first process, what I had done was basically I've done a traversal. Then that can be basically be replaced, but that is being replaced due to the 1000 lines of x0 comparing with xi with a specific number 9. Then again, those 9 steps then I basically changed that traverse to a for. Then I've changed that for to a traverse to a for, and then I had written that those 9 steps. Now in this third part, this final part, what I've done is I have replaced the 9 steps with only 3 steps, which actually emulates, if you actually see, which actually emulates all these 9 statements which I had actually done. This was actually what was happening. This was my 9 steps actually, right? 10 steps. This is only my 10 steps which was happening. So I've actually basically done it. I'm actually increase the number of lines of code. You can see lines of 10 to a 3 over here. So these are my 10 lines of code which I've decreased to 3 lines of code, 3 lines of statements, not code, I'm just statements. Okay. Any doubts? Any doubts?
No, sir.
Please, if you have got any doubts, clear up, because you will later on. What I'm going to do is I'm going to basically convert these steps into. Later on, what I'm going to do, I'm going to use these sets of program, like these things. So what I've done is basically just save it up. Yeah. So I'm going to use this frequency.text later on to actually convert that into a simple program only later on. Any doubts? Any doubts? So developing the algorithm is basically a detailed description of the exact methods. Please note that exact methods used for solving a particular problems. So this was basically a set of exact methods. These were my set of exact steps. So I had converted your idea into a set of exact steps. Okay. Then your data over here is basically, this is your data, X is your data, and this is your information. This is your data and this is your information. Okay. The other way building a rather basically designing a system is actually again a flowchart. This is a flowchart, right? A flowchart has got a lot of symbols. Let's see. It is basically here. So the symbols are something like these. These are the symbols. This is a terminal symbol. So this is the terminal, means it's a start and a stop. It's a start and a stop. I have got an input symbol. This is a rectangle. I've got a processing symbol, which is this thing I input in output. Input or output is basically trapezoid. A processing symbol will be a rectangle. There will be a decision also. So this, if you see that this is a decision. This is a decision, right? Each two outputs, two lines. One is a yes and one is a no. Okay. You can have a 2 branch. This is a 3 branch, and this is a multi-way branch. And these are my flow lines, and these are my connectors. I'll just basically go through the same thing, but I'll just actually show you how do I actually converted this algorithm into a simple flow chart. Let's say. So I start off with a symbol. That is my start. Where is my start? Yeah. So this is my start. right? After that, my start, I require a connector.
Excuse me, sir.
Yes.
So I think circle is used for start, and this is a oblong symbol used for input and output, I think.
No, this is for this is the terminal. This is a terminal of the start symbol. The circle is used for a connector. I'll show you what
Okay,
it is. Okay. Then I require a line. So these are my flow lines. These are my flow lines, right? And I have got input, that is x0 to x1. So I can take my input. Where is my input? Input. So input will be x equals to x1 comma x2 comma dot 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 x100. Okay. Then I have got another flow. Then I have got a connector. Then what I require is basically a for loop, right? So for I equal to 1 to 100. So this is a processing. For I equals to 1 to 100, right? Then another processing. For j equals to 0 to 9. You can notice that my system, my page is being closed off. So I require a simple connector. This is a 1. So this is a 1. For j is equal to this. Now I require a if condition, right? So my line is coming. I require a condition. So this one is to be this thing. xi equivalent. Hello? Hello?
So you are audible.
Okay.
Yes, sir.
So this is a condition. So is xi equal to j? If it is a yes, so I require a connector. I have got only two paths. So if yes, it's a yes. So this one will be a yes. Yes. Then what I'll be doing is that basically there will be processing. Then if so, this one will be if j equals to if j plus 1, right? And there will be a for ending. So there will be another for over here end also.
Sir,
Yes.
sir, you are using different types of figures. So what's the meaning of these types of figure in this chapter, sir?
Which one?
Sir, me, sir, Ali.
Yeah, this is something like this one. So I require a flow chart, right? A flow chart is basically a sequence of instructions with the flow is given. Right. So these are my symbols which I'll be using. So this is my terminal. Terminal, that is a start or an end. This symbol is for input or output. This thing is for processing. This symbol is for using a, and this is my flow lines. And these are my connectors. So if you actually notice what I am actually doing, I'm just converting this set of instructions, these sets of instructions into a flowchart. So a set of instructions, the flow in how your instructions will actually flow, that is what a flowchart is all about.
Excuse me, sir.
Yes.
Sir, you have written is instead of if. I think I have mistaken.
Okay, now if you, this is a decision box, right? So
Yes,
decision box is basically, the symbol is basically, if I am given, if I actually write if over here, then I require a continuous sentence. So this is basically true or a false condition. So I just want to check. So is basically x equivalent to j. If it is a true, or if it's a false.
Okay, sir.
So this
Means
is
we
a
are making
true
a
false.
decision. Yes, sir. We are making a decision that if it is xi equal to j, then fj will count, increase its count. If it is not, then it will not.
I have to give the no. I have not given the no. I'm going to give the no right now.
Okay, sir.
The no is implied in this instruction, in this line, your no is implied. But for a flow chart, I have to basically give you a no. I have to state what the no is, right? So there will be an end for end j. Sorry, not nj. Sorry, this will be a next j. Sorry, excuse me. So this one will be your next j. And there will be another flow. There will be a next I. Right now, I have, for this instance, I have not given a yes of what will happen if it is false. If it is false, then I don't require this part. These are usually straight lines. Please note, even though I'm not giving a straight line over here, this one will be a straight line. Please note that this thing, this line, it is to be a straight line, even though I have. Okay, please note this thing. So this will be a no. And your thing will be basically joined with something like this. So I'll be requiring two connectors over here again. Two. I'm sorry. This one will be a two. And this one will be a 3. 3, and there will be an output again, connector 4, output F0 F1 F9. And where is my terminal? You can give an end or a halt, both are same. So this is, if you actually is your yeah. This is your flowchart equivalent for this set of instructions. Again, I'm telling you, please note that this no is not a curved line. This is basically a, well, this goes something like this one, and then this one, and then this one. This. It goes something like this. Okay.
Sir.
Yes.
Sir, I had a doubt regarding this flowchart.
Yeah. Go ahead.
Sir, while we are connecting next j with connected to for j equals 0 to 9, shouldn't j take the value of 0 once again? Because that's how it flows. So shouldn't we get the same results one after the other?
Come again.
Like
come again,
we are connecting next j with for j equals 0 to 9, but we have initially got our result for j equals 0. Again, if we are getting back to j equals
Okay,
0 to 9.
you're talking of this connected to, right?
Yes, sir.
Yeah. What happens is that you have to basically, so this next will actually basically, this thing, it has to go on till the loop. So for j is equal to 0 to 9, when it's actually basically 0 to 9, it stops it. When j is equal to 9, when after it's basically incremented, when after it's going to, when it is reached basically, after the next step it will actually come out. But this indicates that this j and this thing, these two blocks are actually connected. It just indicates that. Okay.
Okay, sir.
So it's not.
So
it's something like you are saying that even if I do not give money, you are saying that why give the 2? You are saying that why give this 2 connected, right?
Yes, my doubt was we started from for j equals 0 to 9. We took the value of j equals 0 for once. If we again connect it back to that same statement, shouldn't j equals 0 repeat
That will be
itself?
incremented by, that will be incremented again. That will be incremented. So what you can do is basically something like this. Let's take, for example, although actually basically so you can write something like this: step 1, right? And you can even write something like this:
Sir?
Yeah. You can write something like this: step 1. The step 1 will actually indicate that how many it's incremented by 1, or so step 2 means that it will be incremented by 2. So it will be following from, so if I give a step 2, so it will follow from 0, 0, 0, then 2, then 4, then 6, it goes on. So step 1 means that is basically incremented with a only 1. So immediately after your incrementation, if it reaches 9, it's going to come out. Okay, what was another question?
Sir, yeah, sir, I had a doubt. Do we use the double equality sign in the decision box while doing a flowchart as well?
Come again, please.
In the decision box, there is a double equality sign signifying if xi equals to j. So, do we use the double equality sign in flowchart also?
Yeah, the double equality chart actually, but a double equality is basically equivalent, right? It's an equivalent sign. So when I'm saying if xi is equal to 0, so when I'm giving a sign of equal to, it means that basically I'm assigning that value to that variable. But over here, I'm not basically assigning. I'm just basically checking it.
Yeah. Okay. I'm comparing. Yeah.
You're just comparing it. Okay. Any questions? Do you have any questions? But usually I do all these things on the board. So fortunately, since I've got this software.
Sir, Steven, sir.
Yes.
Sir, how are you doing this flowchart? This one, I have something problem, sir. Means step by step, how are you getting the next step, sir?
Yeah, you just compare this thing with this thing. Right. Compare it. So I've got an input. So this is an input. So this is your input. Okay, there is something I'm missing over here. I'm sorry. You can write something like this. Input. So similarly, as I have given something like output over here, and over there, so this will be input over here. So sorry, this will be missing. So input, right? So this one basically give this step also. This is another step which I missed. Sorry, this is another step which I missed. Sorry for that thing. So F0. So F0 will be is equal to 0. So F0 is equal to 0. F1 equals to 0. Dot dot dot. F9 equals to 0. Right. So and there will be another arrow between these two things. So just assume that there is another arrow between. I missed this step, right? So F0 for I is equal to 1 to 9, 1 to 100. So I've given a step over here. So this is by default, this basically means that this is a increment of 1. Then for j is equal to 0 to 9. Then I'm taking this basically this condition over here to here. So I'm saying that is it basically x is equal to j? If it's a yes, then I increase that fj is equal to j plus 1. So for this first step, then j will be basically f0. And if it's a no, then I come back over. I have to give this no. Please note that if is in a flow chart, you have to give if there is a yes, and if there is a no, there has to be a yes. This is very important. So you cannot miss this step. This step is not. This has to be there. So if it's a no, then I just do not do this step, but I just actually come over here, right? So where my next step is basically next J. Then my next I, and then we out. So if you actually compare these two things, these 13 steps, or these two forces, you can see that's all represented in so total flowchart only.
Sir.
Yes.
Sir, we can do it in another way. Like here in the inner loop, you have put in J.
Let's get this right. Let's get this in your whole career, later on. You will see that given a problem, there can be multiple ways of solving a problem, finding a solution, because it's an idea. Okay, you have an idea, another person has another idea, a third person will like bring up a third idea. Okay, so ideas, as many number of ideas they have got, as many number of that many number of algorithms will actually be generated, and that many number of flowcharts can be formed. So this is one way I have actually used it. Somebody had actually basically started that he was going to check through each of the numbers, right? For money, so for each of the boxes, that is for each of the FJ, he was going to whole list, but a whole X values. I did not do that. You might be having another idea. I'm not saying that it's not a right, but at the end of the day, your idea must bring out the objective of what you are actually looking for. I'm not saying that your idea will not be wrong or idea will be right. I'm saying that given a problem, in the future we'll see that given a problem you can have a lot of ways. Let's take out a very simple example. A simultaneous solving a simultaneous solution, finding a simultaneous equation, solving for a simultaneous equation, right? With two variables. One there are two ways of doing it: using by a matrix method and using the replace. There are two ways. Right? So but the problem was that given the simultaneous equation, I have to find out the values of x and y. There are two methods. So there can be multiple methods also. So no two methods it's not right that the two methods will be totally different. Two methods will be not wrong. Will be not right. Two methods will be right. The thing is that how do I actually basically decrease the number of steps to actually evaluate to my objective? My main objective will be that given the problem, how can I decrease the number? How many ways I can do it? Is there a better way of doing it? Can this problem be defined in a better way? Yes, it can be done. Because let's take for example, I could have easily done, let's take for this thing. If xi is equal to j, then if this one has been done, it is basically useless to actually go through the other. So let's take for example, your your value is your x0 is 0, right? And for this in the inner loop only, your first box will be f0 will be incremented. So it's actually useless to go through the f1 to f9. So I could have easily for this thing, I could have easily broken over here to here. Right. So there are ways out. It's not saying that it's not a way out. That's also another way. So with that method, what I'm going to do, I'm actually going to decrease by number of steps. So let's assume that all your x1 to x100, all of them are zeros. So if I go through this flowchart, I have to follow your 1,000 ways. I have to follow my 1,000 steps, because why is there 9? Why is there extra 10 steps? Because of this 0 to 9. If they had all been zeros, right? And if I had actually given a break over here, if I had actually basically avoided this line over here, so my process will actually basically end faster. But how will this actually better work? let's assume if all your numbers are all nines, then this has to basically go through all the 1,000 steps. So how you evolve your ideas, that is very important. That is very important. Hello? Hello?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Do you have any questions for class today right now over here only? Okay. So I'll just see this. Okay.
Hello, sir. I have a question.
Yes.
Which book can we follow for learning C? Are there any books?
When I come to see, I'll tell you. When I come to see, I'll tell you.
Sir,
Yes.
sir, I have a same question, just like the person who asked before me.
Yeah.
Sir, for beginners like me, which book or which material can we follow?
Okay, your first three parts will be basically dealing with this algorithms flowcharts. Okay, so you can assume that for your first class only your algorithms, your flowchart is actually being completed. This part. Okay, so what I'll do is basically I'll share these slides and with these data with files with you. Okay, there are many things over here which you do not require. I'll just sort it out and I'll actually basically give you the best parts. Okay, which is
Sir,
actually
can
required.
you provide us the all the your screenshot of these assignments also?
This is a recorded file. Okay, so I'm going to after this class is finished off, I will share this whole video with you only. Never mind, with the whole class. So at your leisure
Sir,
time, you can actually.
can you give us the PowerPoint tabs?
There is
where
no
you have
PowerPoint for this. There is no PowerPoint for this.
wherever you were showing us the symbols.
That I'll give you. I'll
Experiment
send
the
you.
PDF.
I'll send you all this data later on. I'll send you. Because in these files there are a lot of data which you do not require. Okay. So whatever data is being required, I'll basically sort it out and I'll send it.
So another thing, which book we should follow to?
For this thing, you just try to basically generate some ideas only. I'll give you some assignments. You can actually check it out. You can actually have a look at these assignments. You can try to solve these assignments. But then it's at the end of the day, you have to basically form your simple ways of, you have to study these documents which I'm going to send to you. Form the simple solutions. Okay, you can next class what we'll do is basically we'll discuss on whatever we have whatever we have learned today, and then I'll get to the next part.
So have you given any assignment today?
I have not yet, but I'll do it.
Sir, will you mail those slides to us or will you upload it in a Google Drive or something?
I will basically, I'll actually basically, I haven't decided it. I'll do something.
Sir,
yes.
To me, sir. Sir, while doing any assignment, if we have any problem, then can we ask to you?
Why not? Why not? You must. Rather, you must.
So, sir, what will be the medium to contact with you, sir? Through the
You
email?
can contact me you can contact me by mail only. You can contact me by mail.
Okay, sir.
I am usually available during if the college had been open, I would have been available in my room. But unfortunately, the only way out is basically to actually contact me by mail right now. Okay, there are two mails you can actually have. One is this Jadavpur University, this one, and there is another one of this one. You can actually also check it out. Yes, Proma, that you are right. If the entire flowchart cannot be fitted in one continuous space, then yes, we use connectors to show the continuity in the next column. Right. Exactly. Exactly. Okay. Which software is which one? You don't try to
So,
use this
so
software.
this one for making flowchart, the one
You
you are
use a
using.
simple paper and pen. It is advised.
Okay, okay, sir. Okay, sir. Thank
And
you.
if you are interested in writing drawings, so this is the software's name, Dia.
Okay, sir.
Okay, but this thing I must be telling you, I use an open source. Most of the softwares which I'm using, these are open source. And for the information which I'm going to, this is the operating system which you are seeing. This is Ubuntu. This is an open source. I use Ubuntu, and for your assignments and for your programming, I'll be using GCC. I'll be using GCC compiler. I'll get back what they are and what is it in the next class.
Okay, sir.
Okay, sir.
Okay, sir.
No questions? Any questions?
No, sir. Thank you.
Okay.
Sir, I have a question, but I think this is not relevant to the topic, but still, I just wanted to know that why are we still using C as a language and not C++?
C++ is basically
okay.
C++. But since you know C++, I'll tell you. C++ is basically a higher programming language. Okay, and C is a very generic programming. It's if you actually understand C, you can learn any sort of a programming. C++ is actually an object-oriented programming style. Okay, that is a paradigm which is not adaptable for every instances. Okay, let's take embedded systems, which we'll be learning later on. Object-oriented programming, that is the C++, is not preferred for embedded systems. It is always C. And C is a programming is basic. It's actually one of the basic programming languages. C++ has been developed later on. This object-oriented programming has been developed later on. This paradigm has been developed later on. Initially, it was always a procedural paradigm. This is what we say as a procedural paradigm. Procedural is basically it takes one step by step. Python is again a very recent language. So Python, and with Python, you will see that later on when I'll be basically
Shall we
going
have
through.
Python in your course, sir?
No, you won't be having. No, you don't have Python in your.
Sir, can you briefly describe what is embedded system? Actually, I didn't get that part.
Embedded systems are very is a system. Let's take for example your refrigerator, right? So those are embedded systems.
More like an encapsulation.
Sir, is C++
No.
is there in our syllabus?
Embedded systems are basically small. You can let's say for your calculator. Your calculator can be said to be a small embedded systems, which has got a small memory, small processing power, and all those stuffs.
Excuse me, sir.
Yes.
Is C++ is there in our syllabus?
No, C++ is not there in your first semester. I do not know about. Does have a C++ in their course. I do not know about that. But for your first semester, for this class, it will be only C.
Okay, sir.
And I'll be very much strict about one thing is that since you know all these, I'm talking to all everybody who knows somebody about programming. Okay, if in any case in your programming assignments or in your copies, if I see there is a syntaxes which are from different programming language other than C, I will basically give you a 0. Strict about that part. So you cannot use syntaxes from C++ in your C. I'll be very strict about that.
Okay, sir.
Okay, since I'll close up today only. Okay, next day you'll be next class. With what is the day?
Sir, only one question, sir.
Yes, your next class is on Wednesday. Yes.
Sir, I want to ask you, sir, something. Sir, if I don't know about the sir, please don't mind, sir. I don't know, sir, about the computer anything.
Ishad. Tell me one thing. For today there was nothing about programming. Tell me today's class, did you understand anything or not?
Yes, sir, I understood something, but not the 100%, sir.
Okay, since it is not under 100%, you have to actually study it on your own. Go through the lectures again, see to it, right? There are many things because the time is very short. There will be many things. At the end of the day, Ishrad, I'll tell you one thing. I'm going to teach whether you know computers on programming or not. I do not care. I'll be teaching for those people who do not know any programming. So I'll be starting from the beginning only. Okay. So if you are not adaptable, if you're not habituated with having programs, programming is something like mathematics. The more you practice, the more it becomes better. So try to follow the class. Follow the class. If you have got any questions, just ask. You will see that it becomes much more easier.
Okay, another thing is that
Don't
the
have
why
that.
Okay, sir.
the
Thank you.
And for all
Thank
the
you,
people,
sir.
for all the students who are coming from non-competing backgrounds, please don't have an inferiority complex that your neighbor who knows programming, he knows better than me. No, it's not right. Believe me, I've seen codes from students who know coding and which is actually the rubbish. Yes, Rajeshri.
so another thing where the recording will be provided.
I'll
Like,
be sharing it through your. I'll be sharing it through your mail only. Group mail. I'll share it.
Okay, sir. Okay, sir.
Okay.
Thank you, sir.
Okay. Welcome.
Thank you, sir.
Okay.
Thank you, sir.
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 Thank you, sir. Thank you, sir.
Thank you, sir.
Good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.